In this video, we're going to talk about how you can graph curves using all of the information that we've been able to learn so far. Here's an algorithm for curve sketching. You want to determine the y-intercept if it exists by letting x equal 0, and you want to determine any x-intercepts if they exist by letting y equal 0. You want to determine any holes or vertical asymptotes. You want to determine any horizontal or oblique asymptotes. And if there are any of those, what I do is I put them down on the paper right away. Now, you want to determine in step 5 any intervals of increase or decrease. And we're going to require interval testing for that. And you want to determine any intervals of concavity, which is a second derivative thing, and you're going to do interval testing for that as well. And what step 7 is telling us is that when you do those interval tests, stack them. So in other words, do your first derivative test like this, your second derivative test like this. If your first derivative has key numbers of -1 and 3, and your second derivative has a key number of 1, stack them up and make sure that that 1 is in between where the -1 and 3 are if you read from left to right. Now we're going to determine associated y values of any points where the first or second derivative is either 0 or undefined, and we're going to graph those points. Now, after doing all the graphing we've talked about so far, you're going to probably have a few things sketched on your page, and you're almost going to be able to tell what the curve should look like. But almost doesn't quite cut it either. So you want to remember everything you know about graphs, and you want to take care and concern to draw graphs appropriately. If it should be increasing, make it increasing. If it should be concave down or concave up, make it look appropriate. If something's an asymptote, make it look like an asymptote. Make sure your functions pass the vertical line test. So take care to do all those things to the best of your ability. Draw your best graph. Now, if we are to assume that a function is defined all the way through an interval, and if we've got a first derivative that's positive, then 0, then negative, and a second derivative that's negative all the way through, in other words, concave down, then we're going to have a curve that looks like what you see at the bottom of the page, what I'll call a standard maximum. Similarly, if our first derivative goes from negative to 0 to positive, but our second derivative is positive all the way through, in other words, the curve's concave up, we're going to have what I call a standard minimum. If we have a first derivative that goes from positive to 0 to a positive, and a second derivative that goes from negative to 0 to positive, we're going to have a point of inflection. It's going to look like that. And if we have a first derivative that's negative, then 0, then negative, and a second derivative that's positive, then 0, then negative, we're going to have a curve that looks like this. It'll be decreasing, and then 0, and then decreasing, but it will be concave up and then concave down to the right of the point of inflection. Now, if we have a function defined all the way through, but our first derivative is positive, then undefined, then positive, and our second derivative is positive, then undefined, then negative, then we're going to have a curve that looks like this. We're going to have a vertical tangent to explain away the undefined nature of that first derivative. It'll be a vertical tangent, and it'll be concave up and then concave down. And similarly, if we have a function that has a first derivative that's negative and then undefined and negative, and a second derivative that's negative and then undefined and then positive, in other words, the curve is concave down, then concave up, the curve will look like this, and it will have a vertical tangent. On the other hand, if we have a function defined all the way through, and our first derivative is positive and then undefined and then negative, and our second derivative is positive, then undefined, then positive, we're going to have a maximum with a cusp. And if we have a first derivative that's negative and then undefined and then positive, and a second derivative that's negative and then undefined and then negative, in other words, we're concave down the whole time, we're going to have a minimum at a cusp. And then in later videos, we're going to go through how to graph all of the functions that we just sped through right there.